we're going to use this idea of when we were simplifying these rational expressions to actually talk about what happens when you multiply or when you divide. Well, all we're going to do is, again, appeal back to grade school. When you first learn to multiply or divide with fractions, we're going to basically do the same thing, keeping in mind that, we may have to do some factoring in order to see factors that cancel, but the idea is going to be the same. So if you remember, when you multiply fractions, one of the easier things you'll ever do is you're just going to multiply the numerator straight across. You multiply the denominator straight across. So you have a fraction a over b times c over d. It's just ac over bd. Now when we go to division, it's not that much more complicated. If you remember, when you divide with numbers, or divide two fractions, we'll say, you turn it into multiplication. You turn the division into multiplication, but you take the reciprocal of the second fraction. So you switch the numerator and denominator. So instead of a over b divided by c over d, it's a over b times the reciprocal d over c. And then you just follow the multiplication rule, which means, okay, now just multiply straight across. A times d over b times c. So it's the same rules you learned, like I said, back in grade school for multiplying and dividing with fractions. And fractions are nothing more than rational expressions in the general sense. That's exactly what we're going to be doing here. So these problems may look formidable at the start, but the idea is we're just going to use that same basic concept. Now, when we have a problem like this, where we have all monomials, you notice this first rational expression has a monomial over a monomial. Same thing with the second one, monomial over a monomial. We're going to, what you might have called cross-canceling back in the day. We don't have to factor these, and we don't usually factor monomials. We're just going to cancel common factors going this direction. It would be like, back in grade school when your teacher would give you a problem like, say, 16 sevenths multiplied to 21 twelfths. Right? I mean, if you were to multiply straight across 16 times 21, I got to go grab a calculator. 7 times 12 is 84. You have a gigantic fraction that now has to be simplified painfully. So your teacher said there's a way around this. We can pre-cancel or cross-cancel. Now, don't confuse that with cross-multiplying. That's something totally different. We're canceling common factors diagonally here. And same thing here. So first question is, does 16 and 12 have any common factors? And if so, what is the greatest common factor? The answer is 4. So 4 divides into 16 4 times. 4 divides into 12 3 times. You would cancel those out in advance. You're canceling out the common factors that will cancel out eventually if you were just to multiply them together. Right? You're saving yourself some time and effort here. And same thing here, 7 and 21. Well, clearly 7 goes into both. That's the greatest common factor. Once there and 3 times there. Right. Now, at this point, we could multiply straight across, but I always check one more thing. Just like in the last video, we were simplifying a single rational expression. Well, 4 over 1, that doesn't simplify. 3 over 3, that simplifies even further. So not only can we pre-cancel going across like this, we can still cancel top and bottom, which is just going to be a 1 and a 1. Now, when you multiply straight across, it becomes very simple. 4 times 1 is 4. 1 times 1 is 1, and we don't write a number over 1. So this pre-canceling idea is what we're going to use for this multiplication and, eventually division as well, because it turns into multiplication. Right? We're going to do this crosswise and numerator and denominator. Once you do that, you're guaranteed when you multiply straight across, it will be a simplified answer. So let's try that here. Now, since these are monomials, like I said, we don't factor those. We're ready to start canceling going this way. So here's what I do. If I see any factor in common other than 1, I cancel the whole thing out. So I start with 14x squared y and 28xy to the 5th. Do they have something in common? Yeah, something. So I'm just going to cancel the whole thing out completely. And then I'm going to write above and below what I would have left. So start with 14 and 28. The greatest common factor is 7. 7 goes into 14 twice, into 28 4 times. I just realized 14 is the greatest common factor. Let's do it 4. Okay, let's try again. 14 is the greatest common factor. Goes into 14 once, into 28 twice. Right? You have two factors of x in the numerator. You have one factor of x in the denominator. That leaves you with one factor of x in the numerator. One factor of y in the numerator, 5 in the denominator, leaves you with 4 factors of y in the denominator. Right? So we're cross-canceling here. Likewise, let's go this way. They definitely have something in common. Greatest common factor of 18 and 27, I think, is 9. 9 goes in there twice. 27 3 times. One factor of a in the numerator, 2 in the denominator. Leaves you with 1 in the denominator. 3 factors of b in the numerator, 3 in the denominator. Cancel outright. I'm going to just quickly check. 1x over 3a, nothing but cancel. 2 over 2y to the 4th. Yeah, we can cancel out the 2's. So let's just write y to the 4th here in the denominator. I'll just write 1 in the numerator. And then we're simply multiplying what's left over. 1x times 1. That's 1x. 3a times y to the 4th. 3a times y to the 4th is 3ay to the 4th. And that's our finished product, right? So we simplify through multiplication, same way we simplify when we're just taking one single rational expression. Okay, 2 things to note in the second example. Number 1, you have division. That's very important. What we're going to do is we're going to simply rewrite this as a multiplication problem by taking the reciprocal of the second fraction. Now, while I do that, I'm also going to factor all the numerators and all the denominators if they factor at all. Right? So let's do 2 things at once. This first fraction is going to stay the same, but as far as factoring, x squared minus 6x plus 5 factors into an x minus 5x minus 1. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is that negative 6. Right, just unfoiling. The denominator, I believe that would be x minus 5, x plus 3. Again, negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. A little better job there. Okay, I said division. I am going to turn that into multiplication. And in order to do that, I have to take the reciprocal of this fraction. So this 4x that was in the numerator now goes to the denominator, and we don't factor monomials. 4x is a monomial. 2x squared plus 6x was in the denominator. It's now going to be written in the numerator in its factored form. I believe that's just a GCF of 2x. We're left with x plus 3. Right. So what we've done is we factored, and we've taken the reciprocal of the second fraction. It's now multiplication. And now we're going to do just like we did here. It'll be a little less messy, though. So we can cancel going diagonal. So if we notice anything going this way, which I do not, if we notice anything going this way, which I do, the x plus 3's. And don't forget, top and bottom still work. So x minus 5 in the numerator, x minus 5 in the denominator, those definitely cancel. Likewise, 2 and 4, 2x and 4x are monomials, so 2 and 4, that would be 1 and 2. The x's are going to cancel outright, so we just have to take inventory of what we have left. What do we have left in the numerator? Looks like x minus 1 times 1. X minus 1 in the denominator, looks like 2. That's it. So our final answer, when you multiply these two, is x minus 1 over 2. That's the simplified version of this division problem. All right, same thing here. Now this time we do have multiplication, so we're good. We're not taking reciprocals, fractions, but we do have to do some factoring here. 12x squared is a monomial, so it stays 12x to the second. X squared minus 7x, just GCF. Every time you look at a problem, you say, "Wow, that looks weird. I don't know how that would factor." You're probably forgetting greatest common factor, right? Because if you're trying to treat this as a trinomial, yeah, there's going to be some issues there. Go back and think greatest common factor. That should always be your first move. So we're left with x minus 7 when we undistribute. Again, it's multiplication, so I'm not taking reciprocals here. I will factor x squared minus 5x minus 14. What multiplies to be negative 14? Adds to be a negative 5. That would be a minus 7 and a positive 2. That would do the trick. And 6x, well, that's a monomial. there's no factoring involved there. Right now, as far as what cancels, again, we can go diagonal. We can also go numerator and denominator individually. That still works. So I always go diagonal first. These are both monomials, so we can cancel out the 6 with the 12, make that a 2 and 1. Two factors of x in the numerator, 1 in the denominator will leave me with 1 factor of x in the numerator. Okay, going this way, we have an x minus 7 and an x minus 7 for sure, cancels. And I believe that's it diagonally. Now the question is, how about top and bottom? Well, 2x over x, yeah. The x's cancel, just leaving me with 2. I could write a 1, I really didn't need to do that. Over here, x plus 2 and 1, I'm not seeing anything. So I just circled what I have left over. Just got to kind of sort through this and try to be as neat as possible. What's my final answer? Well, it's 2 times the quantity, x plus 2, over 1. I guess that would be my answer, because we don't write answers over 1. So I would just say the answer is 2 times the quantity x plus 2, or if you prefer, and I do mean or, there's no law saying you have to distribute and say your answer is 2x plus 4, but you're more than welcome to do that. So this answer right here, 2 times quantity x plus 2, is just as good as that answer there, 2x plus 4. Right? And we're going to find out mostly when we do these rational expression problems and we get to adding, subtracting, we're going to tend not to FOIL, we're going to tend not to distribute, and just leave our answers in what are called factored form. All right, get ready for addition and subtraction.